Hello, everyone. Thank you for joining us for our fourth episode of our Securing AI Apps on Azure series, handling user authorization for an SPA app on Azure. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. This session is being recorded. It will be available to view on demand right here on the Microsoft Reactor YouTube within 24 to 48 hours. With that, I'm thrilled to turn it over to our presenters. Thank you all so much for joining us today.
Hey, everyone. So I'm actually not going to be speaking today, but I just wanted to say hi since I'm usually on these. So as you know, I'm Pamela from the Python Cloud Advocacy team. And today our speaker is Matt. You want to introduce yourself?
Hi guys, I'm Matt. I'm a program manager on AI Search, and today I'm going to be talking to you about SPA, or we call them SPA apps on Azure.
Sweet. So we have been doing this series of sessions, and this is the fourth session in our Securing AI Apps on Azure series, and that's our third session specifically about user auth. So if you missed our earlier sessions, you can go on Reactor and you can watch the recordings, and we'll have 2 more sessions after this. So now, Matt will take it away with user auth for a SPA app.
Amazing. Thank you so much, Mela. So I kind of want to start this off with a demo so we can kind of understand what I'm talking about when I say a SPA. So you might recognize this. This is our Azure Search OpenAI demo. You can find it on our AI templates. Basically, what we're going to be covering today is kind of this login button. So you're going to see I'm going to click it. I'm going to log into my account. I'm going to get prompted for my multi-factor authentication, which I'm going to be doing off screen. Just putting that in my phone right now. Once I do that, I am logged in and I can use the app. So basically, we're going to be covering how that works today. So let's talk more specifically about what is a single page application. So it's actually very easy to compare it to a traditional web application. So this is kind of the old days of the web, but it's still relevant. Where basically, hey, you know, I have a web app. I just want to put up a like hello world page. I have some kind of server, and I can just serve HTML content to some URL, and I can just like kind of put it out there. Like I can literally just write HTML. I don't need JavaScript. Single page applications, SPAs. This is kind of where you get into. I want rich interactivity. An app like the one I showed you that involves showing out to OpenAI, it involves using Azure Search. You need to use a lot of JavaScript, and it's kind of complicated because you're switching between views, and you don't necessarily want to redirect the user to a different page. This does require JavaScript. It also requires that you're writing some kind of server that exposes an API, application programmer interface, so that you don't basically need to refresh the page every time to get new content. So a lot of our demos, it's always good when you can actually set it up yourself. So I'm going to be playing a video that's a bit sped up that basically shows you that you can use the Azure Developer CLI to provision the example I just showed you very easily online without very little work. So I'm just going to be kind of explaining these environment variables. Basically, there's lots of customization you can do in our sample as to how the authorization behaves. Going over a couple of these while this is running. You turn authentication on. I'm going to actually pause it because I've now scrolled too far. You turn authentication on using environment variables. You basically say whether or not you want to apply user account control to specific documents. You have the option of basically saying, hey, you know what, documents without access control, everybody who logs in is able to search it. You can customize the app further by basically saying, hey, I want to use a separate tenant for the actual auth setup, which we'll cover more about that later in the presentation. You actually have to kind of provide authentication. So there's this AZD auth login command. What that does is the same way that you saw me logging into the app, you have to do that same process with Azure Developer CLI, so you can actually give it access to the to your subscriptions. So I'm going to go back to where I am. This AZD up command, it's kind of your one-stop shop for provisioning the sample. It will actually prepackage all the code for you. It will run a bicep template. And in this video is a bit sped up. You're going to see that it's actually running some custom code to set up the authentication. I've run it previously just to kind of speed it up because sometimes running bicep templates can take a few minutes. So I'm going to kind of skip ahead so you can kind of see what it looks like while it's provisioning. Basically, what happens here is that it knows that I provisioned it previously, so it doesn't try to re-provision everything. So what you're going to see here is you're going to see there's a script that runs when you run the template called prep docs. It basically takes all the sample data, it chunks it, embeds it, and it sends it to the search index so the sample works as soon as you use it. Finally, what it's going to do is run this command called azd deploy. Deploying app services can be a bit complicated to do manually. You kind of have to go into the portal and fiddle around with some options. AZD allows you to do this completely from the command line without exiting at all to the browser, which is really convenient, especially when you're testing new changes. Like, for example, I can tell you when you're like trying to debug a login button problem, you don't always want to go to the portal to redeploy the code. It's very easy to do it directly from your terminal. And unfortunately, it does take a while to deploy. So you can see that even though this is sped up, this video still is about 7 minutes. And this aka.ms link will take you directly to the configuration for the login. So before we kind of get into the guts of how this app works, I kind of want to go over some terms we use when we talk about identity and access management. So what is identity and access management? It answers the question, ensuring the right user gets access to the right resource. We talk about identity and access management in two general categories: authentication, confirming users are who they say they are, and authorization, which validates users have the permission to complete the attempted action. We want to split up these two steps because they're two different problems. I work at Microsoft. I need to identify like who I am before we talk about, okay, what documents do I have access to inside Microsoft? How do these things actually work? Authentication uses the OpenID Connect protocol, and authorization uses the OAuth 2.0 protocol. There's a lot of kind of authentication, authorization specific terminology. It can be challenging to understand if you don't have any background. So I'm just going to kind of go over some terms you might hear in the space. An auth flow, when you saw me, that dialogue that prompted me to open my phone and enter the password, that is a type of auth flow where basically I'm authenticating. It's an authorization exchange. So I'm actually talking directly to the Microsoft Identity Platform and verifying I am who I say I am, using OIDC, the OpenID Connect protocol. The actual authorization server, which is the thing I'm talking to, this is the thing that's kind of responsible for all the logic of the identity platform. We don't have to worry too much about this because we're using the Microsoft Entra for this. This authorization server issues something called tokens, which are, you think of them as just like these opaque objects that actually allow you to identify hey, you are who you say you are, you have access to protected resource. And then finally, we have the client, which is the actual app that allows people to request access to a protected resource. So basically, like that app that I was showing you earlier, I'm going to switch my screen back. This is the client in that case. Resource owner, this is whoever actually owns the protected resources. In this case, I'm using an Azure search index that's managed by me. And finally, the resource server, which is this demo that you're looking at right now is running on my laptop. So that is filling in the role of the server. Next slide. So when we talk about tokens, we have to go a bit deeper because when we talk about single page applications, there's a little bit more complexity with managing tokens. There's two main types of tokens we worry about. The first I'm going to talk about is the ID token. This is what I get out of the OpenID Connect flow. And this is the token that verifies I am who I say I am. There's a really important note here. We can't really use this ID token to actually call APIs to get resources. Instead, we have to exchange it for something called an access token. This access token uses the OAuth 2 protocol to be issued, And this is what we use to call APIs. So when we talk about access token, if you've ever seen like an request, an HTTP request, you might have seen this authorization header. It has a really specific format. The most common one you're going to see is a bearer token scheme. And then there's going to be a bunch of letters and numbers. This letters and numbers is an encoded JSON blob that contains these things called claims. Think of claims as just kind of it's a JSON object that has a bunch of key value pairs that has a bunch of facts about whoever has the token. For example, I have this as access token here. It says the name of whoever has the access token. It says their email. It says their username. And there's a bunch of other kind of lower level claims that are necessary for the access token to actually work with the resource server. What's really important to note about these access tokens is that they're very cryptographically secure. Because they're issued by the Microsoft Identity Platform and they've been signed, so in this kind of letter and number string, we can actually verify that it was indeed issued by the Microsoft Identity Platform. This means that people can't forge tokens and fake these claims, because if you could just take an arbitrary JSON blob and send it to any API, that's not really secure. In fact, there have been many security issues in the past from online platforms that have not validated these tokens. So it's very important that the cryptographic verification of these tokens is taking place inside your API. So let's talk about getting more into detail here. How are we actually going to take these tokens and access resources? Well, before we get into the actual mechanics, we need to talk about the two different types of access. We have delegated, which is basically giving the app permission to act on your behalf. You can think of it as kind of impersonating you. So a great example of this is actually Azure Developer CLI. When I run an azd up command, it's using my permissions to actually go and execute a bunch of actions in Azure. So it's on behalf of me, whereas app-only access is the app itself is doing the actions. So you can think of like any kind of like long-running daemon. Like imagine you had a server that was just like taking scheduled actions to manage an Azure resource. That's a great example of app-only access, whereas an azd up type action is something I initiate. It's using my identity and my permissions. That's delegated. When we talk about single page applications, we are very much in the delegated access camp. Now, when you talk about these different types of access, you actually need to talk about different types of clients. App-only access is only possible with confidential clients. These confidential clients are capable of maintaining secrets. Maybe that's a password, maybe that's a certificate, but they can kind of really credibly say, hey, I can keep this a secret. I won't leak this password, because if I leak it, someone can steal my identity. And it's that's very powerful because the app itself can take those actions. SPAs, single page applications, they are public client applications, which means, you know, I can open the source code of the page in my browser, even DevTools. I can find the ID. There's no secrets there. In fact, when I have my actual app running, there's not a single secret that is hard-coded into the app. The only thing that's hard-coded into the app is the ID, which basically means it's open to the public. If you have like a mobile app, for example, that's another great example of public client application, because people can just open the app on their phones and use it, and they can reverse engineer it to get any secrets that are stored inside of it. So the key aspect here is that they're both capable of signing in users and acquiring access tokens, but the permission models is different. Public clients typically can only use a delegated model, whereas confidential clients are more prone to using the app-only model. Now that we have that background and terminology, we're going to kind of get into how do we actually set this up? How do we actually configure a SPA to use user authentication with Microsoft Entra? So at a high level, the sample uses this architecture. We've got our SPA front end, and it has a dedicated Entra application just for it. And we've got a backend for the app. This kind of goes back to what I said earlier about the SPA needing an API. There's actually an app services instance stood up actually providing the data for the SPA. That also has its own Entra application, because it also needs to authenticate and basically validate the tokens and use them to do things. Then the SPA backend is going to talk to Azure OpenAI and Azure AI Search, knowing that, hey, the user identity has been verified. I can use the claims in the token to then go enforce access control and do other things that my app might want to do using the user's identity. So in order to actually get these tokens, we need to register ourselves with Microsoft Entra and create a service principal. You can think of a Microsoft Entra application object as being global. There's this concept of a tenant. A tenant is kind of like, think of it as an organization. So in my organization, Microsoft, I can register an application object, and then that application object has a service principal associated with it that I can then use to get tokens with the Microsoft Identity Platform. So let's start getting into some code. So in order to use the SPA model, I actually need to create those two apps. So the code you're going to see here is the client app. This is what the SPA uses. And I'm just going to kind of go through what we're looking at here. First, we set up our graph service clients. We're using the Microsoft Graph SDK, which is now public preview. We are going to create an application object. This application, there's a lot of properties it can have, so we're just going to cover a couple of these. The display name is kind of what the user would see if there's a user that was in the, basically giving consent to the application. There's a consent dialog pop-up that comes up with the name of the app. Sign-in audience, this is a single tenant application. So Azure AD My Org, what it means is, hey, users in my organization should be able to sign into the app. Now, you're going to notice that there's these two things called web application and SPA application. The flow that you saw earlier, the execute, requires what's called a redirect URI. The reason we need this is part of the OAuth 2 handshake, where basically we say, hey, I want a token. And the way the Microsoft Identity Platform gives us that token back is it actually gives a callback to our app through a redirect URI, and it has all the necessary information in the body of the request and the URI parameters. So these redirect URIs are critical. They need to be registered with Microsoft Entra. The reason they need to be registered is because we don't want people taking your application and then signing into it and a URL you don't approve of. If you basically say, hey, let's say there's like another website that kind of tries to impersonate you and sets up your app, they won't actually be able to log users in because the redirect URI is not registered with the platform. Now we're going to talk about required resource access. Apps are great. We can get tokens. We want to be able to do things with these apps. So we need to actually request permissions. There are a bunch of weird looking GUIDs here. You're going to get really familiar with GUIDs if you are setting up apps, because every single permission, this is the user.read permission, which basically lets you read basic information about the user from Microsoft Graph, like their email, their name, their display name. There's a GUID that uniquely identifies that permission. And we also need to talk about the app that permission comes from. So this is the global GUID for Microsoft Graph. There's another resource access in here, which is referring to this thing called server app. And this is where we kind of get into some SPA specific and honestly, any kind of like client server specific things. I register another application that defines its own permission scopes. So why do I need to do this? So in the model that our SPA is using and the sample uses, the server needs to call a Graph API on behalf of the user. We basically take the access token that the SPA gets and we turn it into another access token that the server can use to finally call the Graph API. In order to do this, we need to define our own API. It's pretty easy to define your own API using the Graph SDK. You essentially just have to give a display name, a description, and then what type of access model we're going to use. In our case, we define it as a user API, so it's going to be delegated access. And then we're also going to need the user.read permission on this app as well. And in order to register the app permission, the app itself needs a unique identifier. This API scheme, this is kind of basically saying it's kind of like HTTPS for apps. It's API : / and then the unique ID of your app. This is a snippet. If you want to look at the full code, what I can basically do is I can go back to the source code and I can look in the scripts folder, and there is an auth init.py, which actually contains the full code that you can run and use yourself. Now, you need to actually add passwords or certificates as a separate as a separate call. You cannot set this up while you create the app. In the future, you'll be able to use managed identity, so you won't need to worry about passwords or certificates. You'll just be able to enable managed identity, which kind of lets Azure manage the secrets for you. Unfortunately, this isn't available right now. The server, the SPA server, because there's no user logging in to start the server, it will need some kind of confidential authentication, such as a password certificate or potentially a managed identity, in order to authenticate with Microsoft Entra. Now we need to actually talk about implementing that login pop-up that you just saw. Okay, how do we do this? We can actually use a built-in authentication flow using this was built in app services. It's very easy to use. You basically just kind of set up some settings in Bicep, or you can even do it in the portal. Or if you want it to work on your laptop, like what I showed you, you'll have to use the Microsoft Authentication Library SDK in order to actually set up these flows. It's not too bad to do this, so we'll talk about that next. So at a high level, what exactly is this authentication flow? Well, first, the user visits and they're not exactly signed in. So what's going to happen is we're going to be being redirected to this URI. And I apologize, what's missing here is that we need to actually do the authorization code first. So let me kind of walk you through this as I do it in the app. So I'm just going to log out here. So we're going to kind of start from scratch. Okay, so when I start here, the auth flow hasn't started. So there's no token. If I go to developer settings, we actually can kind of see the ID token claims here. There's nothing here because there's no ID token. So what I do is I click login and I go back here. What's going to happen is I'm going to initiate the authorization code flow. I'm going to go talk to Entra and say, hey, I want to do this. Now, there's two general methods you could do this. You could either do a pop-up or a redirect. In this case, I'm doing the pop-up. The pop-up's nice because you don't ever navigate away from the page. So I'm going to pick my account. So this, keep in mind, the domain here is login.microsoftonline.com. We don't actually implement this code. This is where the whole redirect URI comes in. Because we're on login.microsoftonline.com, we need to actually, once this flow completes, and once I do this authorization code flow, we need to actually get the token back to the page. And how do I do that? Well, once I complete this login flow, what's going to happen is it redirects back, and then there's some JavaScript that I'm running that actually kind of changes the state of the button. So if we go back to this page, this whole exchange just happened. And once I got the ID token back, I was able to run some JavaScript to actually change the state of the login button and kind of unhide some of the, undisable the send message button, so you could start going to actually asking the app questions. So how exactly does this work? Like, how can I actually then take this token and actually ask a question like, what is included in my Northwind Health Plus plan that's not in standard? How do I actually use the token that I get back? Well, once we run the authentication flow and get the token, we're going to need to actually authenticate to the API server. So the way I do that is I send a header. So I'm going to just show you the code because I think it's way easier to do it here. So I have some code here, and I think we might have moved this to. So we have these the decorators authenticated path, right? So if I go to decorators, what basically happens is every time I go into a route in my API that needs authentication, what we're going to do is we're going to try to actually get the token claims out of the header. And when I go to do that, what happens is I go to actually get the header. So I basically get the authorization header from the API. And once I do that, I am able to actually go parse the token and get the claims out. So once I do that, Then I have to run another on behalf of flow, because keep in mind, this is no longer the single page application. I can't use the token that was issued to this to call an API from the API server. I need to get a new fresh token. So what I do is, once I get the token from the header and validate it, I then go and it's very simple. I just use the acquire token on behalf of method from MSAL and basically say, hey, I want to call a graph API. So once I do that, I then get another token that the app service can use, and then finally I can call the API. So basically, what this shows you is that if I want to use a SPA and I want to get an access token from the SPA and use that in the API server, I just have to kind of exchange that token for one that's eligible for use for the API server application from Entra. And when you do it this way, you're basically making your app secure against token forgery, such that nobody can kind of take your SPA and just kind of like say, hey, I'm going to make like a fake version of your SPA and send in a bad token. Using the on behalf of flow makes your app resistant to that. So now let's kind of get more into the SPA specific code, the actual front end. So just like I have that Python backend code, I have very similar looking code in the actual front end. So when I'm using the MSAL.JS code, it's very kind of similar setup where basically, hey, I have to have a client ID, I have to have a redirect URI. So all those same things that we're talking about, the same way I set it in Python, I just use slightly different syntax when I set it up on my front end. I create an instance. It's a public client because we're using a SPA, and we initialize it. Once we've initialized it, we can then basically use a variety of different methods. So this acquire token silent method, what it does is it actually checks to see if an access token has been already fetched and it's cached. The reason we do this is we don't necessarily want to always get tokens every single time. It's not very efficient. We want to kind of improve the performance of our app. There is a cache that MSAL manages. So this acquire token silent checks to see, hey, is there an access token I can use here? If, hey, the token's expired, we need an interaction. There's a variety of reasons you can use an interaction. We can't enumerate them all here, but I then basically say, hey, pop up that authentication code dialog so that I can actually refresh the token, and then I can kind of go along with the rest of my code. I kind of just showed you this, but basically it's a very mirror image in the Python side. I create my confidential client. I have to get my client secret out. I have to specify what tenant I'm using. I basically authenticate the user, and then I actually have to get the token that I can use. So it's that kind of ID token to access token exchange. It's the same thing we're doing here, just in Python instead of JavaScript. There is one more thing we need to be aware of here. It's called cross-origin resource sharing, of course. If you're not familiar with CORS, basically CORS is a security mechanism in the browser to make sure that pages aren't requesting resources they're not supposed to. This is a browser security feature. So you can call any API you want. Like, let's say like I just write some Python code to call an API. That's not subject to CORS. What's subject to CORS is single page applications that use JavaScript that's running in a browser. So in order to set up CORS correctly for single page applications to work, both if you're deploying on Azure to app services, you need to set up the CORS settings in your bicep, and your actual app that you're running also needs to be aware of what origins are allowed. If you don't set this up, your single page application might not work correctly. So it's really important to set up the right CORS headers. It also allows you to support alternative front ends. So if you have a second single page app, it will be able to use the same backend. This is just kind of one of the browser security housekeeping things. And it goes back into why single page applications are more complicated than the traditional ones. Traditional web applications typically don't worry about this, but because single page applications use JavaScript extensively to call APIs, it's important to get CORS right. Otherwise, your app won't work correctly. So that about covers authentication for SPAs. we have a lot of samples available for you. The sample that I showed today, it's available at akka.ms/ragchat. You can learn more about kind of how access control and generative AI applications works if you go to akka.ms/rag access control. And finally, you can check out the Microsoft Entra Developer Center at akka.ms/dev/msantra, and more Azure AI samples at akka.ms/azai. You can learn more about all these different languages, Java, JavaScript, Python, .NET, and a variety of topics. That about covers it. We've got a couple more sessions coming up. July 17th, 7 to 8 UTC, we're going to be talking about data access control for RAG apps on Azure. And July 25th, we're going to be talking about how to deploy an AI app to a private network. So if you're interested, consider checking these sessions out. That's about all I had for you today. I don't know, I guess we have time for questions.
Yeah, thank you, Matt. So I asked to see if folks have questions. I didn't see any yet. But since we have time, could you talk about the fact that we also support using the built-in authentication feature of app service, and like what that looks like on the front end and the back end?
Absolutely. That's a great call out. So let's talk about built-in apps. So security. So if I go into my bicep, so let me see here, to infra. So if I go into main.bicep, right? So basically what happens is their bicep, there's a lot of steps here, but the setting up the authentication is actually pretty simple. What happens is when I set up the backend, I provide a bunch of settings to it, and I go to this bicep file, this core host app service.bicep. And what's going on here is I set up the cores as I was talking about earlier, but if I go into my app service properties and I see this identity provider section, identity providers are what basically enable the built-in authentication. I basically provide, say, I want to use, it's called Azure Active Directory here for legacy reasons, but this is Microsoft Entra. I provide it the apps that I've provisioned. I provide the secret name because this does use confidential authentication. And another thing that I need to do if I want to use built-in authentication, so the same way that I specify permissions on my app, I need to provide those same permissions when I actually am logging in as part of the OAuth 2 handshake. So the login parameters here, this scope equals, basically it's just saying, hey, all the things I need to log in. So if I go back to main.bicep, services, service plan.
Yeah, I think you just went by it with all the.
Yeah, I helped write this at one point, I promise. I just forgot where everything is. Backend, yes. Okay, got it. So when I specify this here, oh, I think we put it as like default parameters, which is always great. Required scopes, here we go, perfect. So basically what's happening here is that I'm basically saying, hey, I want to use all the permissions that server app is requesting. This dot default is kind of a special OAuth 2 syntax. It basically says, give me all the permissions on this app. These permissions that kind of have vague names like OpenID, profile, email, offline access, these are kind of defined in the OpenID Connect standard as just permissions that they do kind of what they say in the box. Offline access is email and profile are typically permissions you want in any app you create because they let you get information about the user. Audience, because I am using the built-in authentication, I have to specify all the OAuth 2 parameters that the Microsoft Authentication Library SDK might hide from me. basically what I'm saying is I'm intending to use this token to talk to the server application. Remember that the authentication that's provided by Azure App Services, it's actually going to be for the single page application. It's not going to be for the server. So all these scopes and audiences are meant for the single page application. So when I do this, basically, once I've specified this bicep, it just kind of works out of the box. You'll basically get a bunch of default login and logout pages. There's a little bit of code you need to write, though, to make it work with the front end. So I will briefly cover that here. If I go into my front end code, most of the authentication code is located in this file auth config. Well, most of the authentication setup code is in this auth config.ts. And essentially, all I need to do to kind of like put it in is basically use some special URLs. So when I have enabled the built-in authentication, there's a couple more URLs that are available to you. There is .auth/me, which all it does is return the token, the access token for the user. And that access token, all those parameters I went over just now, all those, let me see if I can find it.
Is it the access token or the ID token?
The access token.
Okay.
So this contains all the permissions that I specified here. So it's set up to be used with the server app. It has all the right scopes to be used. And then finally, I can use this URL, this .auth/refresh, to actually refresh the token. And if I want to log out, I just go to this URL. So once I've done that, basically all the Microsoft Authentication Library code I wrote, I basically just check. This might be a better example because there's this code here. I basically check to see, oh, like this is great. This method checks if the user's logged in. It first checks the Microsoft Authentication Library SDK, this iPublic client application. It says, are you logged in? Yes. If not, check if the app services token is available. So there's not really an SDK to use the built-in authentication, but it's very simple to use. So it is not too bad. And you can check out this file for kind of some sample code on like how to combine the built-in authentication. Well, more accurate, because you either use the built-in authentication or you use Microsoft Authentication Library. You don't use both. So your code just needs to be aware of both, but typically it's very simple to add that to your code. Most of the complexity is actually in the bicep, because you're basically telling app services all the parameters here that you set up in code here. So that's the main difference.
And what about the token refresh?
That's a great question. So token refresh is handled basically every time you get the token, you need to check if it's not expired. There is an expires on property in the access token, and you can basically convert it to a date. And if the expires on is greater than the current date, you have to get a new one. So getting a new token is essentially just navigating to the refresh URL and then just kind of go on and use that return token instead. But basically, every time you check the .auth/me endpoint, you might be hitting a cache token. So you always have to remember to check .auth/refresh occasionally or whenever the token expires.
Cool. All right. Thank you for explaining that in addition. Yeah. And we don't have any other questions, so I think we can call it.
Awesome. Thank you very much. And please, we have a lot of great sessions coming up, so feel free to check them out.
Yeah, and we actually did just get a question.
I got it.
Maybe we can put this up because I actually am not familiar with everything here. So they created a Vue.js app. Vue is a framework similar to React.
Yeah.
It uses MSAL with Axios. Oh, I think Axios is have you used Axios before? I think it's another NPM package, maybe.
It's like another alternative to Fetch, right?
Okay. So to help me send requests to ADO and Azure Storage. So should they use Axios, or is there something more secure?
Security, again, it comes from the server and client interaction. So You can make anything that uses Axios secure as long as you follow the patterns of talking to your app securely. Namely, does your server validate tokens before it calls APIs? And if it needs to exchange a token for the app it's backing, does it do that? The usage of Axios, and again, I don't know offhand. I think Axios is just kind of a generic request library. You'll have to manually set a bunch of headers. If there's an SDK, you said it was for blob storage.
It says ADO and Azure storage. So, yeah.
Yeah, Azure. So Azure storage. So there's actually a Azure storage TypeScript SDK, which you might want to consider using, which might save you some time rather than re-implementing requests yourself.
Yeah, and I guess it depends when you say Vue.js. I suppose that's also Node.js on the back end there. So so for Python, our backend to do the token validation, we use the the cryptography package, right?
Yeah, the problem with the authentication today is that, so basically if you go into the authentication code here, we don't actually have a cryptographic library like built into the SDK. So we actually have to use the JWT library ourselves and go do this verification. There is probably an equivalent for Node.js or Next.js. I don't know it offhand, but when you go to validate your key, you'll have to write some code that looks like this to validate that the token is from the Microsoft Identity Platform.
Great. Yeah. And this is all detailed in the on behalf of documentation for MSAL, right?
This particular code, there is a sample that we used. I don't think that this particular method is documented in like Microsoft Learn documentation, but it is documented in this Python identity on behalf of sample.
Sweet. All right. Good question. And now we will call it.
Awesome.
All right. Thank you, Matt. We'll see y'all next week for RAG with data access control.
Awesome. Thank you so much.
Thank you, everybody, for joining. Thank you so much to both Matt and Pamela. You can learn more about the series, view past episodes, and register for future episodes at the URL at the bottom of the screen. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat. Today's event code is 23024, and we'll see you for the next one.